Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to predict the water solubility of your products. So let's get into this. Here's a generic equation. So in my previous video we talked about double displacement reactions. So you have your double displacement reaction, you have substance AB, substance CD, the ions come together. So remember, the outside ions come together to form a product. So A and D come together to form AD. And then your inside ions here are going to come together to form CB. So then once you figured out what your possible products are by putting the outside ions together and the inside ions together, and then figuring out what the formula is and making sure that your formula has a balance of positive negative charge, then the next thing to do is to figure out if you have a precipitate or not. Is something insoluble? Are one of these insoluble in water? That's what you're looking for. Or are they both soluble in water? If they're both soluble in water, then chances are you don't have a reaction. Okay, so how do you decide whether AD or CB are insoluble in water? Well, the only way you could do that is by looking at your solubility rules or some sort of solubility chart. So I have here some solubility rules to follow. This is not an exhaustive list of rules. So there could be other things you can add to this, but I think this is a good list of rules to follow for a majority of the substances you would be looking at. If you want something more exhaustive or detailed, you can definitely find some more solubility charts or tables or rules on the internet. So here we go. So rule number one, ionic compounds that involve group 1 metals and ammonium are always soluble, no exceptions. So the group 1 metals, that would be like your sodium, your lithium, your potassium, and so on down that row, as well as ammonium, which is NH4 plus, right? So any compound that involves any of those metals from group 1A or ammonium are always going to be soluble in water, no exceptions. Okay. Rule number two: ionic compounds that have acetate in them, which is C2H3O2 minus, or nitrate in them, NO3 minus, those ions are going to be always soluble, right? So if you have anything that has a nitrate in it, like sodium nitrate, potassium nitrate, calcium nitrate, any nitrate or any acetate is going to be soluble in water, no exceptions. Okay, rule number three. If you have a compound that's containing a halogen like chloride, bromide, and iodide, those are going to be soluble, generally speaking. However, there's a couple of exceptions. One is the silver ion. So if you have silver iodide, that is not going to be soluble. Sodium iodide is going to be soluble. Same thing with the lead 2 ion, so Pb2 plus. That is not going to be soluble with iodide or chloride. So if I have lead 2 chloride, that's going to be insoluble in water. That would form a precipitate if they were to come together. But again, if I have calcium chloride, right, or if I have calcium bromide, those are going to be soluble in water. That's going to have aqueous. Those are going to be aqueous. Next, we have four compounds containing sulfate ions, SO4 2 minus, are insoluble. So we got to pay attention. Here we're switching to insoluble, not soluble. So here we have soluble, soluble, soluble. So the first three rules have to deal with whether or not they're soluble. rules 4 and 5 deal with insolubility. So you got to remember that. So here, it's saying that compounds that contain sulfate are insoluble, that generally speaking, but there are exceptions, right? So the exceptions are barium ions, so Ba2 plus, and again, lead 2 ions, Pb2 plus. So if you have barium or lead 2 ions in your sulfate compound, it's going to be soluble. If you don't have barium ions or lead 2 ions in your compound with sulfate, then it will be insoluble. So, for example, calcium sulfate. Calcium sulfate is not one of the exceptions, so calcium sulfate will be insoluble, not soluble in water. It will form a precipitate. But if you have barium sulfate as a product, that is going to be aqueous. It's not going to form a solid. It's going to be soluble in water. Okay. And last but not least, we have the compounds that contain carbonates, phosphate, and hydroxide. Those again are going to be insoluble, generally speaking. They're not going to be soluble in water. They are going to form precipitates, except group 1 metals. So the group 1 metal ions and ammonium, if they are together with a hydroxide, carbonate, or phosphate, those are going to be soluble in water. Why? Go back to rule number 1. Rule number 1 takes precedence, right? So we know that group 1A metals, metal ions, and ammonium are always going to be soluble, no exceptions. So if you have a group 1 metal with a hydroxide, that's going to be soluble. If you have a group 1 metal or ammonium with a carbonate, that's going to be soluble. In any other circumstance, it's going to be insoluble. So in this case, barium hydroxide is going to be insoluble. Calcium carbonate is going to be insoluble, right? So these are the rules for determining whether or not your product, AD or CB, is soluble or insoluble in water. That's really the only way that you can determine solubility or insolubility of your products. So again, the first thing you need to do is, if you're given 2 products, if it's 2 ionic substances or an acid and base substance, what you need to do is figure out what the products are by doing your double displacement, right? So the outside ions go together, inside ions go together, figure out what the formulas are. Once you figure it out what the products are, or what the possible products are, then use your solubility rules or your solubility table or chart to help you determine the solubility of your 2 products and go from there. So if it's insoluble, then you know you've got a solid precipitate. If it's soluble, you know it's aqueous. Thank you for joining me. That's it for this video. If you like this video, please like the video. Hit that like button. Share the video with your friends and family. Let me know. Also, if you want to, I hope you do, subscribe to my channel. Hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Please do that for me. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, tell me what that topic is. If you have a particular issue or particular question or problem that you're struggling with and you need help with, put that down below. I would love to help you with that. Thanks for joining me and have a great day.